Good evening, everyone. Uh, Thanks for being here for the presentation. Hemant from Dell Technologies, and I am Rahul from Work Onward. Hemant was not able to make up today, so I will be presenting. Let's quickly walk through the agenda. So basically, first we will try to understand that why digital twin is required for the digital storage, although it has been implemented in various other areas, for example, IoT, smart cities, and various other things. Another is we will also walk through the architectural diagrams, where I will also walk you through a couple of the variants of the architecture and the implementation approach. Followed by that, I will give you a quick short demo of how exactly we have done till so far, and some of the technical components using which you can also build in-house, along with the source code which I will be sharing with everyone. And last and not the least, the security and the business value, that how exactly it is, some of the points we will be looking for the security, and what will be our overall return on the investment. Definitely, like right now, digital twin, AI, like it's like a buzzword right now. But what is the current challenges? So that first we need to understand. Take a scenario where you have a very limited time and you have to test multiple hardware integration. So that's where the digital twin can be like one of the way which we can quickly simulate, test, validate, and also try some sort of a multiple combinations. I mean, most of the things over here are quite well understood, but the one takeaway from the previous slide is the opportunity. This is going to create a standard compliant digital twin that will act like a real device. Now, even before we go further, let's first begin with the standard definition of the digital twin given by Digital Consortium. So overall, what I want to convey here is that the digital twin, it's not just an independent system, it's an entire ecosystem of different hardware and software solutions which are integrated to achieve as a desired outcome. Now, what it offers is that over the period of time, your entire ecosystem will evolve, and that's where the digital twin is going to offer you the ability to evolve as the reality changes, and all the what do you say, like all the simulation and everything, it will be near to the real time. So that was all good for the standard definition of digital twin, but here we are focusing on the storage. So these are some of the pillars, I will say, which we will be using across the further slides, where we will reference all these things. So one is definitely that we want to simulate the actual resources, and another is the standard the common standards for the Redfish and the Swordfish, and finally they are tied to the JSON responses. Now this is where we begin, that we try to leverage the open standards. So for example, DMTF Redfish, SNIA Swordfish, and the JSON schema for the standardization. And what's the end goal? That the final system, what we will get it will be predictable, interops API, and this is what our vision is. just imagine that you are trying to simulate different storage operations. For example, data protection, DR, and various other like volume creation, deletion, so many things. Now just imagine that you can simulate all of them virtually just using simple prompts. So for that, first we need to create the devices, and the devices which are created, we need to know whether they are the valid as per the JSON specification, and then after some of the operations which we can do over there. And finally, instead of like creating just one, we can have like n number of devices within few minutes. So this was the overall like for to begin with, that the foundation. Now let's look over the architecture, that how exactly we are going to accomplish this. So when I tell the architecture, I want to set a benchmark even before that. So the benchmark is, think of it that you are given a specification, and then after your task is that from simple natural language prompt, you will be performing each and everything. Now here are three main components: prompt processor, simulation engine, and the recording generator. And then after, whatever the devices are recorded as per the directory and the specification, those will be used for the digital twin. So I want to set up an expectation here that the demo which I will be showing you, it will be till the device generation using simple prompts. And then after like couple of things like device failure simulation and the device creation. So along with that, I will also show you. So let's quickly deep dive into each of the three components over here. So the very first is the prompt processor. This is where you will need the specification of DMTF Redfish, and then after you are going to have it more in a context aware. So from this slide, take this as like a takeaway, that here you need to very carefully craft the prompts. I have a different slide where I will be explaining some of the best practices, what we can use it there. The next is the simulation engine. So I will say like this is the core of the architecture, where the one end goal here is that when we simulate those the operations, then after whatever the JSON is created, that needs to be validated. Without validation, it's of no use. And last is the recording generator. Over here, I will say whatever the devices are created from the simulation engine, those JSON is passed, and from here we just create the devices as per the specific directories and the subdirectories as per the Redfish devices, which eventually will help in the rapid prototyping, design, development, testing, and whatever the operations you want to perform without a need of actual hardware. Now, whatever the slide I showed you here, so this is the basic fundamental one. I will also walk you through the alternate approach. So the alternate approach, what is here is that just below the architecture, you see couple of blocks. So for example, to make it like little more refined, instead of in the prompt processor block, we can have an embedding generator where you can see PG vector, and there it's like it's yet to be implemented. So this has not been implemented yet. Now there we can use the embedding generator, So along with that, we can have some sort of a knowledge graph, knowledge retriever, and in par with digital twin, we can also have analytics generator and the insight integrator. All of them has to be in conformance with the validation and compliance. And whatever the output we will get here, that will be fed to what we want to achieve through digital twin. So till here, I just walk you through whatever we want to achieve for the storage with respect to digital twin along with AI. Now, going further, what we see is that when we put AI along with digital twin for any specific use case, that's all good. But there are some of the area where we want to refine it more further, which is, for example, reducing the hallucination. I will not go deep dive into the hallucination, but that's just one of the use case I'm talking about. There are some sort of what do you say, when we talk about the complete life cycle, that device generation, validation, then after simulation, we want to have them in a more controlled and explainable way. So going further, we can have something like agentic AI along with digital twin. So for doing some of the operations, we have like team of agents which will be performing all sort of activities. For each of the agent, they will give the response, and that will be passed to another one. So what I want to convey here is that the architecture, what you see on the left hand side, it incorporates a reasoning and planning agent that decomposes task into subtasks and coordinates various specialized agent tool with a guided execution. Here is one very simple workflow, a scenario where we have put it a agentic flow for the digital twin. Now imagine a storage vendor who is building all flash array. So we have like how many? Like 5 agents working together. So there are specs agent which detect the new Redfish schema. Second is the config agent which generate the JSON tree for the NVMe config. The validation which corrects schema error if any and ensures there is a interops between different device vendor. There is also a scenario agent which we are mostly interested in. For example, if we want to perform a HA failover or different task. Now, the one outcome here is that the engineers, they will start integrating months before even the actual prototype hardware arrives. So, like till now, all the theories I have just walked through. Now, let's walk through some of the demo. So, as promised, I will go through basically 3 demo. One is the device creation, another is complete end-to-end infrastructure solution, and the last is UI for the device status change. So if you see here, so basically here we are just creating a device, and the device is created as per the directory structure. And this is the infrastructure simulation. So this is just the output, that when we simulated for the complete infrastructure, which we named it like AI/ML ready, and it has created like 4 resources. It is showing how many counts are there, and the status is generated. So till here, these are just the generated ones. Now here's the very simple one where I'll just play it. You just write as a simple prompt that what you want, and just for the example, I'm creating here a storage volume, but instead of this, you can create any device you want. You can expand, and even when I hover over it just show you in a more detailed. And you can also see the API logs, REST API execution and all. And here you see the devices being created as a JSON. And now I will just try to disable the devices. So whatever we are changing here, that is also getting changed in the JSON. And now we just enable it. So this is a very simple example of that, how exactly we can do AI integrated with the digital twin. And here's the complete the device recording. Now let me move next. So this is quite long, maybe like for 5 or 6 minutes. So I will not walk through all of them. I have uploaded all this thing on GitHub where you can just go and check. So this is a complete infrastructure simulation where you initialize the Redfish profile, and then after all the devices along with the specification, they will be created. So, and you see all the recording of the devices. Okay. So here's like a QR code where you can just access this, and I will also be sharing the presentation. Now this is all good. Now here's the discussion part where we talk about the contribution, some of the example and the best practices for the prompt engineering, tooling and stacking, security and guideline. So let's go through the contribution. So first of all, it is device agnostic, and I will also say autonomous. What we want to focus here is the last bullet point, which says zero touch extensibility for the scalable simulation. So what it conveys is that it is architected for seamless code-free onboarding of new resources type, supporting rapid standard-based simulation across the heterogeneous data center environment. And here's like what I was talking about earlier in the with respect to the prompting, that you need to have in the lang chain we have like a pre-recorded already existing prompt templates which we are using. So the prompt we have written, and some of the best use case, some of the best practices will be that we can give a few short example of the sample prompts, and then after we can just a second. Yeah, so that's like one of the way, and we can also provide JSON mode schema guided sampling for the constraint decoding. And as usual, we will be performing validation using the conformance checks, which we can do like a self check. Here is one of the example of the tooling stack, which can be, like you can build this with the common well supported tools. So container will manage and scale, and event bus handle telemetry and job that will be used widely for the JSON schema and Open API validator. So this is like one of the very simple stack which can be used to build this. And like one of the key takeaway from this slide, I will say for the security and governance is the policy guardrails, that we need to have some sort of a guardrail when we do all the promptings. And the first bullet point, it is quite, what do you say, like well understood. And here we have the outcome and the ROI. That the first is, it is having a very short validation cycle because we can create the devices on the fly. The second is broader coverage. Then after, we also do interrupts of the devices. And the last but not the least, which is we can design anywhere and we can test anywhere. And here are some of the key takeaway, that what we achieve with this is the speed and the scale without any actual hardware. The second is standard compliant validation, which is also like a multi-layered validation which ensure both structural and semantic accuracy while leveraging Redfish and Swordfish specification for a guaranteed interrupts. So this comes with when we implement the embedding, which I spoke in the earlier slides where I talked about putting an embedding layer over there. And another is that the organization also achieve a significant ROI through the shorter validation cycle. And the last is the zero-touch onboarding of the new devices. So thank you so much for your time. I'm open for questions. Yes, please.
My name is Trent Johnson from IBM, and looking at our capital budget for next year, I can definitely see the value in what you're proposing here. So who do you think the main types of users would be for this technology from the Dell perspective? Would it be their clients or their development teams, or I mean, who is this project really targeted for?
So the question is, with respect to the use case of the given presentation, who will be the right users for this AI-based digital twins? So to answer your question, I think initially the right users will be the internal team who are developing the like hardware, software, and everything for the clients. So internally, it will be the internal team. I mean, that's how we started. Thank you. Any other question? Yes?
So most of this is focused on sort of the standards compliance or specification compliance, which is great. Good to see. Is the same approach going to work for, say, performance simulation? Kind of referring back to the HPE Labs talk that was earlier, where they're really focused on simulating performance in CXL.
Yeah, so just to put the question again, the question was that whether the same digital twin, the implementation which I shared, whether that will be applicable for the performance-based testing. So my take here is that when we talk about the performance, it is something like which should come from the actual hardware which we are doing. But with respect to this, even if we do it using digital twin, it is not going to be the same near to real representation. So it might not work specific to the performance part, because that brings, because we also need to address, there was one slide which I have not put it here, that was with respect to the uncertainty estimation for the hallucination part. So that will create, so that need to be fixed. Thank you. Thank you. So if any question, you can just email me. Thank you so much.